Hey guys, this is Zach. So today we're going to do chapter 2.4, which is piecewise functions. If you don't know what a piecewise function is, we'll go over that in a minute. But first, let's do a little review on a few of the basic types of functions that you're going to see. So the first is your constant function, which is y equals b, where b is a constant. And that's just going to look something like this. As x increases or decreases, your value is going to stay the same. You're also going to have your linear, which is y equals x in the most basic form, and that's going to be your average line. As x increases, y is going to increase directly proportional to that. So like 1, 1, 2, 2, so on and so forth. Then you have your square function, so parabola. And that's y equals x squared. As x increases, y is going to increase at a steeper rate. It's going to increase to the square of x. So as x gets 1, it's going to be y is going to be 1. As x is 2, y is going to be 4, and so on and so forth. And then your square root function is only going to be positive like this. As x increases, y is going to increase at the root of x, so at a slower rate than x. And all the other ones had a domain of all real numbers, and this one, however, has a domain of all positive numbers. And the range is going to have to be positive as well, because the function is only going to be above the x-axis, and it's only going to be to the right of the y-axis. Next, we have the cube function, which is y equals x cubed in its most basic form, and that one looks something like this. So this one, the domain is all real numbers. It can go. The range is all real numbers, so there's no really limitation to y equals x cubed. And then you also have y equals cube root of x. It's a cube root function, and that looks like this. So that one's also all real numbers for the domain and range. Your last two functions are going to be your reciprocal or inverse function. The book calls it the reciprocal function, but I've never really heard that used before. Everyone calls it the inverse function, and that's y equals 1 over x. So that's probably what your teacher will refer to, or anyone you talk to. So that one looks like this. And so I put these ends like this rather than being an arrow because there is an asymptote here. An asymptote is a line that the function is going to approach infinitely but never actually reach. So this function will continue on and get infinitely closer to this axis, but it will never actually touch it. And you signify that with the little half arrow. So same with here, here, and here. So these are all going to extend out and get closer and closer to this axis, this direction as well. So that's your inverse function. And so it's basically all real numbers except it cannot equal y equals 0 or x equals 0 because those are the axes, and it never actually reaches the axes. Your final function that you should memorize before moving on to piecewise function is your absolute value function. And that one looks like this. It's like a linear function, except instead of the line continuing on down here, it stays positive. It stays positive up through here. So for that one, your domain is all real numbers. Your domain is all real numbers, but your range can only be where y is greater than or equal to 0. Because absolute value can't have negative numbers. Okay, so now on to piecewise functions. Piecewise functions it's a group of different functions with different sets of domains. So let me write an example for you. This is how you would see it. F of x equals, and then let's say negative x plus 1, 2, and x squared. And then you'll see a little brace here. And then on to the right of that, it'll have the domain for each of them. So this one, negative 3, 1. So you use that function, use negative x plus 1 function if x is between the domain of negative 3 and 1. For 2, it's if x equals 1, and for x squared, it's if x is greater than 1. So that's what a piecewise function looks like. It has, in this case, it has 3 functions. It has a linear function, a constant function, and a square function. And so you can use each of these within its designated domain. So what you do with these, what the main question you're going to be asked in the book is, it's going to ask you to plug in points and say, what is the value when x equals 2? And in this case, you're going to want to find the domain in which that value lies. So if it asks you to find x equals 2, you're going to belong in this one because 2 is greater than 1. It doesn't belong in any of these. So then you plug 2 into this function because that's the corresponding function, and you get 2 squared, and so you'd get 4. Now if it asks you what's the value of f of x when x equals 1, that belongs in this, and when x equals 1, the value of the function will always be 2. So that's your answer. And then it'll ask you to graph it next, most likely. And to graph it, you just have to, within each domain, graph that function. And these inclusive versus non-inclusive, this is inclusive, this is non-inclusive. You signify that with an open versus a closed dot, which I'll show you in a second. So here I have the piecewise function graphed. So as you can see, the linear function, negative x plus 1, from x is greater than or equal to negative 3 to x is less than 1, is signified here. So it's a closed dot right here because it's greater than or equal to negative 3. And it's an open dot here because it's less than, not less than or equal to, but just less than 1. So you signify that with an open dot. Same with the quadratic x squared for x is greater than 1, open dot, and then continued on to infinity with the x squared function. And then when x equals 1, we said the function said the output was going to be 2. So at 1, we put a closed dot at 2. It's not actually at 2, it's pretty close though. It should be at 2. It's my fault, but and you can see that this is a function because it passes the vertical line test at each point. When it gets to 1, it comes down here, but they're only 1 point here. These are open dots, so they're not actually at the point 1. So this is a function. And then the next question will probably be asked with one of these problems is it continuous? And to check continuity, you have to look and make sure to see if, the way I always learned is to see if you could draw the function without having to lift up your pencil. So if this one, you'd be coming down here, you'd have to lift it up to come to this one, you have to lift it up again to come over here. So we'd say this is not continuous. The real definition of continuous would be everything's connected. So if this one connected perfectly into this one and then went and connected perfectly into the next one. As you can see here, it's not continuous at x equals 1 because there's some disconnect between the 3 functions. If they all came and met at the same point, if these two were open and this one was closed and they all met at the same point, it would still be a function and it would be continuous. However, here it is not continuous at x equals 1. The next thing would be domain. We already went over domain. For this one, the domain is you take the smallest and the biggest values of the domain because it's a piecewise. So it started at negative 3. So we'd want to say that the domain is x such that x is greater than or equal to negative 3. And that's it because the very last function, x squared, actually continues on forever. So it just has to be greater than or equal to negative 3. The range, however, is a little different. I'm going to say y such that y has to be greater than 0. Not greater than or equal to because it's an open circle down here. So, and although this one doesn't continue on forever, this one does continue on forever in the y direction. So you can either say y such that y is greater than 0, or you could say 0 comma infinity. That is also an acceptable notation. Infinity meaning it goes on forever in the y direction, and 0 is the lowest value. And then we have these parentheses because it's not inclusive. You can never include infinity, and 0 is an open dot, so it's not inclusive. If it was including 0, meaning this was a closed dot, we would write it like this: 0, infinity. But infinity is never inclusive because it's not a real number. You can't actually get to infinity. So we just use parentheses. That's not really important, but yeah, just make sure you distinguish between these notations too, or you can just use this one. Either one is acceptable.